Hi guys, welcome back to our channel, and today we're going to talk about mathematics. So what mathematics is for?
Each of nature's pattern is a puzzle, nearly always a deep one. Mathematics is brilliant at helping us to solve puzzles. It is a more or less systematic way of digging out the rules and structures that lie behind some observed pattern or regularity, and then using those rules and structures to explain what's going on.
Acceleration is a subtle concept. It is not a fundamental quantity such as length or mass. In fact, it is a second-order rate of change, that is, the rate of change of a rate of change. The velocity of a body, which is defined as the speed with which it moves in a given direction, is just a rate of change. It is the rate at which the body's distance from the chosen point changes.
In order to handle questions about rate of change, Newton and independently the German mathematician Gottfried Leibniz invented a new branch of mathematics called calculus.
One of the strangest features of the relationship between mathematics and the real world, but also one of the strongest, is that mathematics, whatever its source, eventually turns out to be useful. It changed the face of the earth, but again, the ideas sparked by this discovery were different for different people.
Mathematics is the science of patterns, and nature exploits just about every pattern that there is.
Physicists went off looking for other laws of nature that could explain natural phenomena in terms of rate of change. They found them by the bucketful: heat, sound, light, fluid dynamics, elasticity, electricity, and magnetism.
The story of calculus brings out two of the main things that mathematics is for: providing tools that let scientists calculate what nature is doing, and providing new questions for mathematicians to sort out to their own satisfaction.
Whatever the reasons, mathematics is definitely a useful way to think about our nature. What do we want it to tell us about the patterns we observe? There are many answers. We want to understand how they happen. To understand why they happen is different. To organize the underlying patterns and regularities in the most satisfying way. To predict how nature will behave, to control nature for our own good, and to make practical use of what we have learned about our world.
Mathematics help us to do a lot of things, and often it is indispensable. It is also an understanding of how a system works. It is both applied and pure.
This common cycle time is called the period of the system. The individual bodies may have different but related periods. When a resonance occurs, all of the participating bodies must return to a standard reference position after a whole number of cycles, but the number can be different for each. Another function of math is prediction. Also, by understanding the motion of heavenly bodies, astronomers could predict lunar and solar eclipses and the return of comets.
We can use mathematics to relate the resulting geometry to all different variables, such as growth rate and eccentricity of growth, that are involved. Mathematics also shows that ice definitely can evolve gradually and naturally, offering increased survival value at every stage by the means of the amount of light it bends.
We should not expect new mathematics to give an immediate dollars and cents payoff. The transfer of a mathematical idea into something that can be made in a factory or used in a home generally takes time. Resonance, which is the relationship between periodically moving bodies in which their cycles are locked together so that they take up the same relative positions at regular intervals. This common cycle time is called the period of the system.
In contrast, it is much harder to predict the weather. We know just as much about the mathematics of weather as we do about the mathematics of tides. But weather has an inherent unpredictability. Despite this, meteorologists can make effective short-term predictions of weather pattern, say 3 or 4 days in advance.
So, what is mathematics really for?
Mathematics doesn't just analyze. It can predict how all kinds of system works. From the aerodynamics which keep the planes flying, to the amount of fertilizer required to increase crop yield, and even to the complicated calculations that keep satellites in orbit around the Earth to sustain internet and network to our mobile phones. Mathematics is the cradle of all creations. Everyone needs mathematics in their day-to-day lives. May it be a cook, a farmer, a doctor, a scientist, a musician, and even a magician. Mathematics can help us understand the world around us, to make sense of our place in history, to make decisions, to interpret, quantify and communicate, and to see another layer of beauty in nature. Mathematics is everywhere. It is not only for scientists and mathematicians. It is for everyone.